Hello, everyone. My name is Rick van Bruggen from Neotechnology, and here I am again recording another episode for the Graphistania podcast. And tonight I'm joined by Caleb Jones, all the way from Seattle in the US. Welcome, Caleb.
Thanks, Rick. It's
I,
great to be here.
I asked you how to pronounce your name, and I make a mistake. I'm very sorry.
Oh,
It's
that's all
Caleb,
right.
right? I apologize. So, Caleb, why don't you introduce yourself? You've been very active in the community and your blog and everything, but it will be good for you to introduce yourself to our audience if you don't mind.
Sure. Yeah, and again, thanks for the opportunity to kind of sit down and chat. I've been kind of involved in the graph space for years now. My introduction to it actually did come through Neo4j. That was kind of my first intro into the
Oh,
space.
did it?
Also focused a lot on doing graph analysis. Um, And as you mentioned, run a blog. I run a blog called allthingsgraphed.com, where I post some of those analysis. It's really a labor of love. I'm not getting paid to do it at all. It's just a way for me to kind of just express what I'm exploring and some of the insights as I play around with the graph space.
Hmm.
And like you mentioned, I'm in the Seattle area. Professionally, I work as a software engineer, now recently a software architect for Walt Disney Company.
Excellent, excellent. So yeah, and I've been reading your All Things Graph blog for quite some time. You've done some amazing posts on there that I really enjoyed reading. Do you mind telling us a little bit about some of those experiments? I'm particular
Sure.
fan about the antonym synonym pathways thing, but there's a lot of other interesting things.
Yeah, so and if you don't mind, I could just kind of dive right into, what kind of led me to do that
Yes, please.
initially.
Yeah.
Um, Really so I mentioned Neo4j kind of turned me into the graph space, kind of opened the door. And then I ran across this essay called Science and Complexity that Warren Weaver wrote. And he wrote it back in the mid 20th century. And it kind of lays out these epochs of science. He calls a problem of simplicity, where you have one element acting on another, problem of disorganized complexity, where now you're looking at things at system level, but not in terms of the interactions of pieces in there, but then also a problem of organized complexity. And so this is mid 20th century, and he says, well, problem of organized complexity is really what we're going to need in order to start addressing things like the complexities of medical, psychological, biological, political, economic sciences. And he saw as a kind of a blocker towards us starting to really explore those problems of organized complexity, the compute resources. So again, this is back in mid 20th century, 1948, and he's seeing how there's this kind of new form of scientific exploration and analysis that once we have computational power that's up to the task, we'll be able to start diving into.
Hmm.
And to me, that just screams graphs, right? You have graphs that they're really designed around that concept of elements and their relationships or interactions with each other. And then as you start building up that graph and then start doing network-wide or graph-wide analysis, you start to have these insights. And so it's really that turned on a light bulb for me. And I said, wow, you start seeing graphs everywhere. And I said, well, I've started writing some tools and some code that allows me to do these kinds of analysis, and so I don't have to write code every single time. And that's really what led me to, well, I'll start blogging about this as I start playing around. So that's what kind of led me to how I got here, how I got exposed to graphs, and why I'm where I'm coming from in my blog.
Yeah, yeah, yeah. And in one of some of the experiments, you've done some really interesting experiments. Well, what's your favorite one or that you've done so far, if you don't mind
Yeah, so
elaborating a little bit?
yeah, definitely. So I try to keep a variety. Right? I don't want to do the same analysis over and over again. So I try to use different sorts of data sets and different topics. And so I've gone away from kind of a microscopic, where I did one on, protein interactions of budding yeast, and then even kind of looked at, well, what do some of those molecules look like? And right, a molecule is a graph, right? You have atoms that have certain kinds of connections to each other, right? And then molecules interactions, that's a graph, and so forth. And you build up, and then all the way up to my favorite one was the stellar interstellar network navigation using graph analysis, and that one was a real challenge, but also a real joy to do because astronomy is a big life passion of mine, and so that was a really an intersection of a lifelong passion and technical skill set at the right matched up with the right data set, and so that was my favorite one.
That's the one that you presented at Graph Connect, I think, right? And there's a video about
Yeah,
that and
yeah.
everything. Yeah,
Mhm.
yeah, very cool. And it's funny that you mentioned this protein interaction. That was actually one of the first projects that got me into, more of a practical Neo4j insight as well. There was a research group here at the University of Ghent that was doing metaproteomics, protein-protein interaction analysis for beer yeasts. and
Hmm.
that's one of the first interactions that I've had as well. So it's funny that you mentioned
Yeah.
that.
Yep.
I think you've already touched a little bit on, why is it so powerful, so interesting for you? It's all about dealing with this complexity, I suppose. But are there any particular things that you really, really enjoy about graphs that you don't find in other data structures or
Yeah, so one thing that I really enjoy about graphs in particular is it starts to address these kind of topological questions. What I mean by that is when you start analyzing a graph and its features, you really start to get insight into the emergent properties of that data set or that system. And so, for instance, in an economic graph or network, what you would start to see is key brokers of transactions in that network. And then there's examples like eBay using that for fraud detection and things like that. In the medical sciences, I've mentioned that post I did on budding yeast proteins and their interactions. You can start to tease out what are some of these key proteins that are involved, and when you look at that, turns out that that's kind of a fundamental building block that you see across different kinds of types of life, and so that's the sort of insight that when you're only looking at an individual protein in that instance, and then only its immediate connections, you're not going to get that kind of an insight. Versus when you start looking at networks and doing things like page rank analysis, betweenness, centrality scoring, and so forth.
you can look at like system-wide effects, right? You can look at the
Right.
entire interaction rather than just a local interaction, I suppose.
Right. And you start getting emergent properties that in some interesting ways aren't necessarily strictly reducible to any one element in the network, right? It's really an attribute of the network as a whole.
Super interesting, and in so many practical applications as well. I mean, as you know, I work for Neo as a commercial guy, right? As a salesperson, I see so many applications, in business and from logistics to financials to cancer research. There's so many applications of this stuff. It's really quite amazing.
Yeah.
Super. Maybe one last question, if you don't mind. Where do you think this is going, or where do you want it to go, or where do you want to take it yourself? What does the future hold, Caleb?
Yeah. So, I mean, it's hard for any of us to say, but I think graphs are really poised to start being a tool that can be used to answer or provide some sharpness to our answers of some really big questions. It was one of the kind of key things I talked about at the last that Graph Connect presentation in San Francisco is finding what are the big questions that we want answers to in these different areas, whether it's astronomy or biology. Taxonomies like Word, I find in WordNet. I've done a few analysis on Wikipedia. What are some of these big questions that we can start answering? And how can we use graphs to sharpen our answers to those questions? That's what I kind of see coming out as we start using graphs more and more. For me personally, I know, in the last couple months, I've haven't been posting on my blog. I have a few that are kind of building up. One is I've actually started scraping political candidates' websites and starting to look at those. But I
This is
don't
the
want
year
to
to
just
do it, right?
yeah, yeah, definitely. But I want to do a new kind of an analysis where I'm starting to scrape the topology of those connections, but also the content, and then do the analysis and then do produce word clouds that are segmented based on that analysis to really kind of tease out what are these what what are these what does the language really tell us about these candidates, and so that's one thing that's kind of on the horizon for me. On the astronomy side, I actually got my hands on a data set from a um, universe kind of simulation from a colleague from the Los Alamos National Laboratory, and basically try to replicate the same sort of analysis I did previously on a stellar network, but do it at a galactic simulation level. So that's another thing that's kind of next on the horizon for
Wow.
me. Yeah.
That'll be something big. Wow. I actually talked to someone from NASA a couple of months ago that was using Neo4j as well. So
Uh-huh.
that was super interesting as well. Anyway, Caleb, I think we're going to wrap up here. I really appreciate you coming online and talking to me about all of this wonderful stuff. I'll make sure we have enough links to all of your great articles in the
Sure.
transcription when we publish it. So thanks a lot. Really appreciate it. And I hope to meet you at some future Graph Connect.
Yes, definitely. Thanks for taking the time.
Cheers, man. Bye.
Bye.